we are repeating part of experiment 13 and doing something more. So we have two solutions. One is a grape Kool-Aid, and one is called the Dylan Kool-Aid, and it's called like this because it's prepared according to one of the students. One of you years ago prepared his own Kool-Aid, and since then the school has been using it. So this Dylan is one of the Chem1A students of a while ago. Okay, so these two Kool-Aid solution, one is the commercial one, is grape Kool-Aid, contain these two dyes. The Allura Red that we use in experiment 13, and here there is the concentration. In addition, contains the Brilliant Blue. There is another dye, they are all food dye, that has the concentration is written here. The concentration of the dyes are also written in your manual. Why do we need to know the concentration of the dye? Because we're making dilutions, right? And we're using M1V1 equal to M2V2 to figure out what is the concentration of each dye. So in experiment 13, what did we do? We already were provided the amount of solution that we needed to use. For solution 1, we needed to use 2 milliliters, then 4 milliliters, then 6 milliliters, and then 8 milliliters. These were the solution that we needed to prepare. Do you remember? Mm-hmm. So here you are told what are the solution that you need to prepare. In this experiment 14, you are provided only with one solution, which is the solution that has 3 milliliters on it. So you find out, so what you're going to do is you're going to prepare the solution like you did in experiment 13 by putting the 3 milliliters, adding to the marked water, and you're going to use this solution for two purposes. One, you're going to use this solution to find the maximum absorbance at the and you're going to check the absorbance of your 3 milliliter solution, the solution that you prepared by diluting 3 milliliter. You're going to do again the absorbance from 560 this time to 660. We're using a different calibration curve, a different range, because this is blue, it's not red, okay? Once we find what is the maximum value of the absorbance, as we did the last time, also for the Brilliant Blue, we are going from that maximum. Let's say that this maximum is 700 nanometers, okay? You're going 705 and 695 nanometers, so plus minus 5 nanometers, to find out if that value is really the maximum or if you need to go a little bit lower or a little bit higher, okay? Once you have done that, this time you have to do something more. You find what is the absorbance of your solution in which you did dilute 3 milliliter of Brilliant Blue, and then you have to figure out, based on that absorbance, how much low and how much high. So you have to use half the amount, 1.5. Let's see where it is. Here. You need to figure out what is the amount of Allura Blue that you have to use to go from an absorbance that is a bit 0.1 to 1. If, let's say, you found that your absorbance, I'm making up a number, okay, was for that maximum lambda value was a 0.4. So what you need to do, because you have to go from 0.1 to 1, and you have to have 4 data points, what you're going to do, you're going to maybe divide and get to 1.5 milliliter and see what is your absorbance. It should be half of it, right? So 0.2. You might go to 1 instead. It's your call, 1 milliliter, and then you get an even lower value, right? Then you double these milliliters. Let's say that you use 6 milliliters, okay? And so this will be 0.8. I'm making up the numbers, okay? You will find out what is the absorbance. And then you go to 6, times 2, I don't know, 12 milliliters. And maybe you will find this 1.2. So maybe you have to go in between 8, 7, 9. So it's you're uptenting. The important thing is that you have 4 points to have your calibration curve. So starting from 3, you divide enough, you multiply by 2, you multiply by 4, you figure out what is the amount that you have to use for your dilutions, okay? Once you have done that, you're going to measure the absorbance of these 4 solutions. In the same way you made 4 solutions for experiment 13, you're going to make 4 solutions for experiment 14. And then you're going to perform the separation from this solution that contains the mixture of the Allura Red and the Brilliant Blue. You're going to separate in 2 solutions using chromatography your mixture. So here you have the mixture of these 2. You need to separate them and find out what is the concentration. How do you do that? Let's see how. So chromatography is one of the techniques that we studied at the beginning of the semester when we were working on purification processes. So chromatography is a technique in which we have either a polar or non-polar substrate that is in this cartridge here, and we put in, first condition the cartridge. So the way we do it is we wash it with 70% isopropyl alcohol to clean it up completely, because it might have been used by people that didn't clean it well and left the column in this way. So this column cannot be used anymore. So we want to bring them back to white so that we can keep recycling them because they're expensive. So you take this column and you prepare syringes. Syringe with 70% isopropyl alcohol, a syringe with 2 syringes with 70%, 2 syringes with 25% isopropyl alcohol, 2 syringes with 5% isopropyl alcohol, and 2 syringes with deionized water. And then 1 syringe with the Kool-Aid, and you choose if you want to use the grape or the one from the recipe of the student, okay? It's up to you. You have to write it down, okay, which one you're using. Then what you do is you take the syringe, you have 10 milliliters. Let's say that I have 10 milliliters of the deionized water, so let me pick it up here. Okay. So you mount first. Let's assume that you put your water in your container. So you're going to have 5 containers that you're sharing with your classmates. And what you're going to do is you're collecting the solvent, whatever you're going to use it. Right now I'm using water. You flick so that you don't have any bubbles. And then you go to you push the piston so that you go to 10 milliliters, okay? Once you have the 10 milliliters, you load on the column like this, and you push down the deionized water. The deionized water activates the column. okay, the cartridge. Then you clean with, first you wash with the column with 70% isopropyl alcohol in the way that I just showed you. Then you wash with the ionized water. These two go in your waste container. Then you load on the cartridge your unknown. So your unknown will be sticking, sticking to the top of the column. Okay? This is a mini column. And you can choose between the two. Then you do an elution with 5% of isopropyl alcohol. Why we cannot use 70% isopropyl alcohol? So these two compounds, if you look at the molecule, we study the polarity of molecules, have different polarity. This column is a non-polar column. And we learn, like we learn with magnets, that things that are polar attract each other, things that are non-polar don't attract each other, right? So this one is very polar. This one is non-polar. So what we need to do is we need to use the 5% to push out the red band of the Allura red, and so we'll have a clean vials, clean and dry vials, in which you're collecting the first band is the red band here. Red 40 or Allura red is the same thing. So the first band will come out with a 5%. The blue will stay on top of the column, will be stuck, because you need a much more polar solvent to push it down. So elution means to push down the solvent, like you saw with the deionized water, and you obtain the first red band and you put in the column. To collect all the red, you add one more syringe of 5%. They're always 10 milliliters. We need to know why they are 10 milliliters, because then we have to figure out what is the concentration, right? Using M1, V1 equivalent to V2, okay? So based on absorbance, we get the absorbance. We find out for our unknown, based on the absorbance, what is the concentration, okay? And using M1, V1 equivalent to V2, this V2 is diluted, right? We know that it's diluted. So we need to figure out what is the initial concentration of our sample. Okay, so we collected the first 5%, then we can collect again 10 milliliters of 5%. Why? Because even if we cannot really see the red, there is still some residual Allura red in your solution. So we need to collect it all. Then, once we finish to collect in tube number 1 the Allura red, we collect in tube number 2 the brilliant blue. For the brilliant blue, we need a much more polar solvent, okay? So we're going to use a 25% brilliant blue. We collect in tube 2. We repeat again, so that we make sure that we collect all the brilliant blue. We have to keep in account how much solution we're using. Are we using 20 milliliters? Are we using 5 milliliters? Until the cartridge becomes completely white, like it was before. Then, before we measure the absorbance of our two bands, we clean the cartridge immediately with 70% deionized water and with 70% isopropyl alcohol and deionized water. All this waste goes in the can go inside the sink, because I don't know if we have the organic waste, okay? I'll check. If we have the organic waste, it's going to go in the organic waste, but it's alcohol and food dye, so these are harmless solvents, okay? Once we've done that, you're going to measure the absorbance of the first column and the second column LU8, okay? First is going to be the red, the Allura red, and the second one is going to be the brilliant blue. You are going to use your graph to interpolate the data and find out what is the concentration. And then you will find using A equal the constant times the wavelength times, the distance. There is 1 centimeter of the cuvette. You will find out what is the concentration. And you determine the concentration of the two dyes in your unknown, okay? That's all we are going to do. Do you have any question about the procedure? Is it clear? Are we sure? Okay, so let's look again how we use the instrumentation to avoid any confusion in case it wasn't clear. So we have our blank that just dropped. So let me put some more blank. We fill it up to almost to the top. We clean it up with tissue. We have it here. And in order to obtain the curve for the Allura, for the brilliant blue, first we set up the wavelength at 560. Okay, so here is 546. We go up to 560. We calibrate the instrumentation with the blank. When the blank is reading 0, then we put in our solution of brilliant blue. And we start to collect our data, okay? So we start to collect the first one, and then we keep going on and on and on until we get our maximum. When we reach our maximum, we go 5 before, 5 below, and we obtain our absorbance. Once we have done that, we prepare our other solution based on that value, and we obtain these 4 points. This number that I gave you here are not the real number, are number that you have to determine, okay? And then you're going to do the separation and the determination of the concentration of the two dyes into that mixture, either the grape and the Dylan mixture. Okay? Any questions? No questions? Okay.
Okay. So this is experiment 14, and this is the blue dye we're going to be using. So record it, and it's also in your manual, so for any other information you might need. So first we're going to be making a 3 milliliter dilution of this dye. So I'm going to add Now that we've added 3 milliliters, we're going to be filling the rest with deionized water. And then once we start getting closer to the mark, we're going to be using a pipette until the meniscus is right across the line. Now, once we've added once we've added the deionized water, we're going to put the stopper and we're going to mix it 10 times.
Okay, so we are going to zero the machine, and we're going to we put in the blank, we have the 0 here, remove the blank, clean with paper tissue our solution in which we diluted 3 milliliter of the brilliant blue, insert it, and do the first reading. We remove it. We increase of 10 units the nanometer of the wavelength. Again, tear the instrument, zero the instrument. And again, clean the solution, insert it, and read the new value. And we keep going until we reach 600 nanometer, 660 nanometers, excuse me. And we continue until we reach 660 nanometers. Notice that now the absorbance is starting to decrease. So we increase 10 more nanometers. So we're already past our maximum. And this is our last measurement at 660. So we found the wavelength at which we observed the maximum. We go back to that value. We measure the blank again, one more time. We go 5 nanometers above and 5 nanometers below, so let's go up 5 nanometers. Measure the blank. This is the value, 5 nanometers above. Now 5 nanometers below. And based on that, we choose which one is the correct wavelength of the solution that we prepare using the 3 milliliters of brilliant blue. Based on this absorbance, we calculate the concentration to go from 0 to 1 to the absorbance of 1, and we prepare 4 solutions, either diluting the solution of 3 milliliters or increasing the concentration of the solution from 3 milliliters to higher values. Once we figure out during the calculation what are the 4 solutions that we need to prepare for our calibration curve, we measure the absorbance of each solution. So we start from the blank. We set up our maximum, then we put in our blank, zero the instrument, start from the least concentrated solution, and you need to show your calculation on how you found out which one was the correct concentration on your notebook. We record the absorbance of the most diluted solution. We tear again this instrument, and then this was our middle solution, the 3 milliliter solution that we used to have a reference for the absorbance that we needed. Calibrate again in between the measurements. Then we load the concentration that is a little bit higher, the 3 milliliters, the one that we use as a starting point, and we collect the absorbance. One more blank. And then we collect the absorbance of the most concentrated solution. Remember that you have to do in lab the calculation to figure out what is the concentration of this fourth solution, and then build your calibration curve of absorbance versus concentration. Now we are going to perform the separation of the mixture of Cool Aid and the way we are going to do is we are going to prepare 2 syringes for a series of solutions. So we have the 5% isopropyl solution, and here we have prepared 2 solutions, 25 isopropyl alcohol and 2 solutions, 10 milliliter each syringe, 70 milliliter percent isopropyl alcohol and 2 more solutions. And I'll show you here how we fill up the syringe to prepare our solution. So we go above 10 milliliters. We have a waste here. We look at the mark of 10 milliliters, so I'm not up there yet. We look at the mark, and we flick the syringe so that there are no bubbles, and then we go up to the 10 milliliters. So this is for the deionized water, and these are for the other solution. Same thing with the Cool Aid. We collect also for the Cool Aid 10 milliliters. We go above the 10 milliliters, as we did earlier. And then in our waste, here is the mark for 10 milliliters. First we flick to eliminate every bubble, and then we we push the piston so that the upper part is on the 10 milliliters. And we do this for both times. The first thing we do is we clean our cartridge with 70% isopropyl alcohol. So this is our waste container, and we push through our cartridge the 70% solution. Once we're done that, we rinse with deionized water our cartridge. So the first step is to make sure that our cartridge is really clean. So we push the deionized water through to make sure that no isopropyl alcohol is left over. Then we load our Kool-Aid on the column. So that we double check there is a 10 milliliter. We load it. And as you can see, it stays on top of the column. Once we have done that, so this is our Kool-Aid, whatever you have chosen. We push through on tube 1 the 5% isopropyl alcohol, which should isolate only one of the two dyes, the red one, as you can see here. To make sure that we collected all the red, we push one more 5 milliliters. So in total, 10 milliliters. We have to keep in account all the solution that we are pushing through our cartridge. This is going to be our solution 1 that should contain only the Allura red. Notice that the solution now is blue. The cartridge is blue. So now we add the 25 milliliters in the second tube. So we load our solution, double check there is a 10. And we see the brilliant blue solution coming through. We want to make sure that we collect all of it. So we elevate our column with 25 more milliliters, or 25% isopropyl alcohol, excuse me, until the solution is clear. And there is no more blue. At this point, we wash our column immediately with 70% isopropyl alcohol, and this goes again in the waste. And then we remove the excess of alcohol with deionized water. Now the cartridge is clean. We now use these two solutions to determine their concentration, and then we'll perform the calculation to determine, based on the calibration curve that we have. Actually, we are going to measure the absorbance, and using the calibration curve that we have built with the Allura red and the brilliant blue, the Allura red from experiment 13 and the brilliant blue from experiment 14, we're going to determine what is the concentration of the two dyes in the Kool-Aid. So let's move to the spectrophotometer. We mix our solution because, do you remember, we added twice 10 milliliters. So we want to be sure that the concentration is the same throughout the test tube, and we place the Allura red in our cuvette. Here's the first one, and then we do the same with the next test tube. We mix it up to make sure that the solution is homogeneous and the concentration is throughout the tube the same, and we collect in another test tube, in another cuvette, the brilliant blue. Now we set the maximum at 500.
What is that?
According to experiment 13. And we read the concentration of the absorbance of the Allura red, and then by interpolation we obtain the concentration. So first, as always, we set the blank, and then we measure the absorbance of the Allura red that we separate from the Kool-Aid. This is the value. And then we set the wavelength at the maximum that we had for the second experiment, experiment 14. Again, we tear the instrument with a blank. And we measure the absorbance of the brilliant blue that we obtained from the grape Kool-Aid. So this is the value. From these values, using the equation that we saw during the explanation, we determine the concentration of the two solutions.